All right, good afternoon, everyone, and welcome to MOS Live. My name is Becca, my pronouns are she and her, and today I'm going to be your moderator for our virtual planetarium exploring space. If you're joining us on Zoom and would like to see captions, you can click on our closed caption button at the bottom of the screen and select show subtitles. If you're joining us on Zoom and would like to submit questions or comments at any point, you can do so by clicking on the question button and typing in anything that you would like to share with us. If you're joining us on Facebook and YouTube, we are super excited that you're joining us. However, we are not able to see any of your comments at this time, but we do hope that you enjoy following along with us. So with that, I think it is just about time that we go ahead and get started meeting our educator for today.
Thanks, Becca. Hi, everybody. My name is Katie. My pronouns are she and her. And today I will be your educator and your pilot as we explore space. So today's topic is a little unconventional, maybe a little morbid, because we are going to talk about not all, but a lot of the ways that you could die in space. Last week was Earth Week or Earth Day, which is the day that we show support for environmental protection and just our overall love and gratitude for our planet Earth. And so I kind of thought that it would be appropriate to then talk about why we should appreciate the Earth, because there is nowhere else that we know of that could support us and keep us comfortable, right? Humans have evolved to live in the Earth environment. And so we have things like oxygen in the atmosphere that we need. We have water, we have the right atmospheric pressure. And a lot of these things we don't tend to think about because they don't really affect our daily lives. We're used to it. But as soon as you venture out into space, it becomes a lot more apparent just how important these things are needed to survive. So I have us right now in a program called NASA Eyes. This program is pretty great. It's free. You can download it or use a web version. Again, it's called NASA Eyes, and it also keeps track of all of the current and past and even future missions, particularly NASA missions. And so I just have us kind of in orbit around the Earth here, but I will bring us a little bit closer to the International Space Station, where there are humans living and working all the time. Now, it doesn't look like it's very far away from the Earth, and it's not. It's only about 250 miles above the Earth's surface, but these astronauts have to be fully equipped to deal with the environment in space. So the first kind of general topic that I'm going to cover today is what would happen to the human body if it was exposed to the vacuum of space. And to start off, let's see, I'm going to kind of keep switching between this particular program and also a PowerPoint that I have. So this slide here tells us a little bit about spacesuits. So when the astronauts are on board the ISS, they're performing science experiments, and sometimes they need to actually leave the International Space Station and go on a spacewalk. And a lot of this is because they need to just do general maintenance on the International Space Station. Sometimes they need to retrieve something. There's just a whole lot of reasons why astronauts might need to perform a spacewalk. And so they have a ton of protection. Their helmet, for example, is coated with gold so that it protects the astronauts from really strong sun rays, so radiation, specifically ultraviolet radiation. The Earth's magnetic field does that for us, and the ISS isn't too far away, so that it is still within the magnetic field, but our atmosphere also protects us from a lot of the radiation from the sun, which astronauts do not have out there. So they need that extra protection. They've got, the entire suit itself, which is really well insulated, and it's also equipped with a cooling system so that the astronauts don't get too hot while they're out there performing their spacewalk. They've got a backpack that's got electricity, ways to communicate with Houston if anything goes wrong. It removes the carbon dioxide that's exhaled. It's got air in there. It's pressurized. And of course, they have gloves, right? So they have to be fairly dexterous when they're out there. In addition to protecting their body, they also need to be able to use their fingers. So there's specialized gloves that can help for dexterity. So there's a ton of work that goes into making astronauts safe. So let's talk about what would happen if, your body was completely exposed to the vacuum of space. So one of the things that we hear a lot, especially in science fiction, a lot of movies and things like that, is that you would, if you took off your helmet out in space, you would immediately freeze to death. When that's actually not the case. Don't get me wrong, you can still freeze to death in space, but it's very unlikely that that in particular would be the way that you'd go. But I want to address it anyways. So in this particular graphic, this is the orbit of the ISS. And when the ISS is on the daytime side of the Earth, it actually receives a ton of radiation from the sun. So temperatures can get extremely hot. So if you were to do this on the daytime side of the Earth, you'd actually completely burn up just because of the sheer radiation and the heat blasting from the sun. While if you were on the opposite side of the Earth, on the nighttime side, it would be very, very dark. And then you might last a little longer. So in space, there are no molecules. There's no air, no nothing, no oxygen, no nitrogen, just nothing around you. It is literally just space. So there's no convection or conduction, which are the two ways that things tend to be heated here on Earth. In space, since there's no medium for heat to transfer or to travel through, there really isn't any of that conduction or convection happening. So the only heat source or the heat transfer is by radiation. So if you didn't have a spacesuit on and you were on the nighttime side of the Earth, it would actually take a very long time to freeze. It would take anywhere from 12 to 26 hours before your body would actually start to get cold enough to freeze, because your body has its own internal temperature. And because radiation is the only way to transfer heat, radiation is very slow. And so you would lose your body heat at a very slow rate. So you'd stay warm for, a decent amount of time. But plenty of other horrible things would happen to you first. So let's get into those. As I mentioned, there is no air in space. You are in a vacuum. So one of the first ways you could go is by hypoxia. So this is basically a lack of oxygen. You wouldn't have anything to breathe. And as soon as, this is apparent to your body, right? Normally you breathe in oxygen, it goes into your bloodstream, your blood then carries that oxygen to all of your various organs, and then it takes the carbon dioxide and brings it out of your body, right, through exhaling. But if you don't have oxygen to go to your various organs, like your brain, for example, you'll fall unconscious. And it takes about 15 seconds for deoxygenated blood to reach your brain, at which point you would fall unconscious. After that, you would still stay alive for a little bit. You'd be unconscious, but you could probably stay up for another minute or so before it wouldn't be, looking too good. And that kind of brings us to our next point. So can anyone tell me what astronauts and deep sea divers might have in common? Feel free to just type it into the Q&A and Becca can read your answers for me.
We're giving folks a few seconds to think about this. And it seems like some people might think that they need to breathe. There might be hypoxia or, I guess, lack of oxygen.
Yeah, absolutely. You need to bring your oxygen with you, whether you're going to space or if you are going deep in the water. But in addition, and it kind of comes along with it, there's a significant pressure difference in both of these environments. So when you're on the surface of the Earth, we experience something called atmospheric pressure. It's the weight of all of the gases around us exerting on our bodies. And it's like just under 15 pounds per square inch. So every square inch of your body, there's 15 pounds pushing against it from our atmosphere. Again, we don't realize it because we're used to it, right? Humans evolved in this environment, so we don't notice it. But if you've ever been to like the bottom of a swimming pool or really deep into the ocean, you can start to feel the pressure from the water around you, like in your head, and you kind of have to get your ears to balance out. It's the same thing in space, right? So I mentioned that there's no air in space, which means there is no pressure. So when you go from an area that has a very high pressure to an area with very low pressure, if you move through these environments too quickly, you can experience something called decompression sickness. So when a diver dives super deep into the ocean, they have to do it very slowly. And then if they come up too quickly, what can happen is that this rapid change in pressure can cause bubbles from dissolved gases in your blood to start piling up. And this can lead to things that aren't, super awful, like just joint pains and, minor pains like that, headaches. But if you do it too rapidly, you can actually rupture your lungs. So when deep sea divers are coming up from a very deep dive, they have to do it over a very long period of time. We're talking like, it could take up to a day, like 24 hours. Astronauts have to do the same thing. So before they prepare for a spacewalk, they have to go into a decompression chamber, and so that they get slowly acclimated, not to the total vacuum, but just to a lower pressure, because astronauts actually breathe pure oxygen. It's the only way that they would get enough oxygen at a reduced pressure. So even though they're not getting acclimated to no pressure, because then that would be really bad, they are getting acclimated to a less pressure. So if you were to just be completely without any protection in space, that rapid change would cause those bubbles to form. It would cause your lungs to rupture. Any of the fluids on your body, so like your saliva or the moisture in your eyes and face, would evaporate immediately. So it's not just temperature that changes elements, I guess. So if you think of like water, for example, and when you're boiling water, you have to boil it at 212 degrees Fahrenheit or 100 degrees Celsius, but you can also change the pressure instead. And so if you get to a low enough pressure, you can boil water at room temperature. So that would also happen if you were just exposed to the vacuum of space. Like all of the fluids in your body would just start bubbling up, and it'd be a really bad time.
Those sound like some pretty awful effects, but we do have a quick question kind of related to that.
Sure.
Josie's wondering, in sort of at the bottom of the water pressure pushes you down, but in space, is it hard to walk because of the difference in pressure?
Oh, interesting. That's a good question. I don't think that it's hard to walk because of the pressure change, because again, humans are protected by their spacesuits, and inside the spacesuit, they are pressurized. So it's not completely like what we're used to here on Earth, but they are pressurized. The main thing that makes it really hard to walk in space is that the gravity, you're in a microgravity environment. So you're just kind of floating around, you're in perpetual free fall, as if you were skydiving forever, pretty much. So that definitely makes it very difficult to walk, to move around. You have to you pretty much use your arms for everything in space, not so much your legs, unless you want to push off something or something like that. That's a good question. Have there been any others?
Yes, we also have one. Do they need to change their air a lot when they're in space and kind of get a refresh?
That's a good question. So they basically are fully equipped with all of the oxygen that they will need on their spacewalk. I don't think there's any way to really deliver more to them. I could be wrong on that, but I'm pretty sure that they just bring all of the air with them in like that life support backpack that they wear when they are going on spacewalks. Inside the ISS, that's kind of a different story. When they're inside, it's pressurized. There's air. It's not pure oxygen like it is in their spacesuits, and that is probably a complex system of chemical, I don't know. I don't know how it works.
Awesome. Thanks, Katie.
No problem. But I'm really glad someone asked about what it's like to walk and move around in space, because that kind of leads us to our next unfortunate demise, and that is becoming untethered. So when you're in space and you're performing a spacewalk on the ISS, every astronaut is tethered to the actual space station itself. Because if you were to ever become untethered, there is nothing to stop you from just floating away forever. On Earth, if you were to like push a cart or like a stroller or something down a sidewalk, then eventually it would come to a stop, right? Because there's friction between the wheels of the stroller and the sidewalk that slows it down and eventually resists the force of your initial push. In space, friction is not really a thing if you're just floating without anything around you. So, if you became untethered and you weren't able to grab onto anything at the last minute, you would just keep floating on forever, basically until your oxygen runs out, which would be not a great way to go. Or I guess hypothetically, if you had a very unlimited supply of oxygen, eventually your orbit would decay so much that you would just come burning you would burn up in the atmosphere of the Earth, which also doesn't sound like a great way to go. This picture that you're looking at right here is an astronaut named Bruce McCandless, who actually performed an untethered spacewalk back in 1984. And I don't mean that he's just floating out there with no life support whatsoever. He's actually wearing a MMU, which stands for a manned maneuvering unit. So it's essentially a jetpack. So that force that's released from whatever gases are present in the propulsion system, the jetpack, allows him to control where he's going in space. And this was the first test of it. It went very successfully. But they did, after this particular test, NASA created another unit very similar to this. It has a different name. It's called SAFER. I don't remember what it stands for. But every astronaut now that performs a spacewalk wears one of these SAFER devices in the emergency scenario of if they were to ever get untethered for some reason, or couldn't grab onto something. So there are lots of safety precautions put in place, essentially. All right, so far we've talked about things that have never actually happened, really. Nobody's ever experienced, being completely exposed to the vacuum of space, and nobody's been unintentionally untethered in space. But this next one actually did happen. And I just want to preface this astronaut is totally fine. He is completely safe, but a very scary thing happened to him back in 2013. And this next one is going to be a little surprising. You can also drown in space. You wouldn't think so because, there's not really any water up there. How on Earth would that happen? Or how on not the Earth would that happen? But it did happen to this astronaut named Luca Parmitano. He's an Italian astronaut, first Italian astronaut to actually perform a spacewalk. So back in 2013, he was on a spacewalk with fellow NASA astronaut Chris Cassidy. And they were just doing some maintenance on the International Space Station. And after about an hour, Luca realized that there was some water in his helmet. And he thought maybe because they have a little bag for water that they can drink out of, he thought maybe that had leaked somehow. But then over time, he realized there's actually a ton of water in his helmet. Like he couldn't see anymore because, again, they're in microgravity. So water just clings to things. Doesn't stay at the bottom of the helmet or anything like that. So it clung to his eyes and his nose, and it completely stuck to the visor of the spacesuit, obscuring his vision, so he couldn't see anything. It went around his mouth as well. And so he was able to call to Houston and tell them that this was happening. So they terminated the spacewalk. Chris Cassidy grabbed him by one of the many little dongles on his spacesuit, and they went into the decompression chamber to get back into the ISS. And so he was able to he came back completely safe. He was totally unharmed, but his life was in danger because he literally almost drowned from a near meter of water not a meter, a liter, excuse me, of water that had been floating around in his helmet. So not that's definitely a scary one, but he is safe, which is great. All right, so for the next few, so those were just 5 of many. The next few that I want to talk about are kind of more hypothetical. They're questions that we get a lot from people all the time, like what would happen if you fell into a black hole, or what would happen if the sun explodes, things like that. So before I get into that, I'll pause and see if there's been any more questions.
We do have lots of questions, and I know we can probably save some for the end too, but we did have lots of people saying that they were thankful that there were a lot of safety precautions in place and that ended up being a happy story. And we also have someone wondering, how could that water even get in there? Wouldn't he have had to open his helmet?
That's a great point that I failed to explain. So the water actually came from the spacesuit's coolant system. There was a blockage in the filter. Again, not sure about the specifics about how it works, but this blockage in the filter caused a leak from the coolant system. And so, a lot of folks have been like, couldn't he have just drank the water that was, near his mouth or something like that, which, I kind of thought of that at first, but because it's part of the coolant system, it probably wasn't safe water to actually ingest. But it was a leak because of the coolant system that's inside the suit.
That makes sense. Thank you. And we did have quickly just a few questions about kind of life on the ISS. Someone was wondering, how do you bathe in space on the ISS? And someone else was wondering, what do they use for light? Because we're wondering about electricity in space.
Yes, both great questions. So astronauts, when they don't actually take a shower, because again, they're in this microgravity environment, so it would be very difficult. Water just floats around. So they actually do kind of a sponge bath type of thing, where they have special it's almost like a powder shampoo type of a thing that they use, like dry shampoo and special rags and things like that. So that's the type of cleaning that they do. And then the other question, electricity. Yeah. So those massive so what you're looking at right now is like the main modules of the ISS. And then on the 2 sides there, those rectangles that are sticking out are actually solar panels. So they get all of their energy from the sun.
Awesome. Thank you. We do have some more questions, but I feel like we probably have a few more things to talk about first.
Sure. Yeah. So I think what I'll do is I'll talk about black holes, because everybody loves that, and I'll also talk about maybe what will happen to everyone when the sun starts to run out of fuel and die, because that's one I get a lot. But first, I'll preface it with saying that the sun is never actually going to explode. That is called a supernova, and only extremely massive stars can go supernova. Our sun is a very average star, so it will not explode at the end of its life. It's about halfway through its life right now, but it has another 4.5 billion years to go. So you don't have to worry about any of this happening very soon. But what will eventually happen is that the sun is going to expand. Average stars, when they start to run out of fuel, they puff up, they get really fluffy, so they become less dense, and they get really, really hot, and eventually just blow up like a balloon. Not actually blow up, I just mean expand. And then they get really hot. So let me go ahead and switch back. What you're looking at right now is kind of the next step in the process. So let me get us back to NASA eyes so that we can see the sun up close here. So the sun right now is about, if you were to put Earths kind of across the center, you could fit about 100 Earths right across. So that's its length and diameter. But by the time it expands and becomes a red giant, it would actually engulf the orbit of Venus, which is all the way out here. So it would get really big, really hot. The Earth would no longer be within the sun's habitable zone, or the zone that liquid water can exist in. So anything on Earth would be completely fried. And then the new habitable zone would be out by Saturn, actually, like super far away. So maybe even some of the moons around the outer gas giants would be more habitable at that period. And then once the sun kind of goes through this red giant phase, it eventually just keeps shedding its outer layers until it becomes a nebula, where all that's left is the core of the star that is called a white dwarf. And there's no more fusion or anything happening in it. The star is essentially completely dead. But all of this material may go on and create new stars, or be involved in other processes in the universe. So that's one way, although it is worth noting that in 4.5 billion years, when the sun expands and boils the Earth away, that all life on Earth will probably be gone anyways. So not really something you'll have to worry about. All right. And then the last thing, with 2 minutes left, is death by black hole. Of course, spaghettification, right? That's always a fun term. Black holes are the basically most massive things in the universe, or supermassive ones are anyways, and they form from really massive stars dying and collapsing in on themselves. All of that material gets squished into a period at the end of a sentence, but actually even smaller than that, an infinitely small point. And so there's a lot of mass concentrated in a very small area. So anything that gets close to a black hole, the tidal forces from its gravity just basically tear you apart. So the gravitational force at your feet would be so much stronger than the force at your head if you were near a black hole, that you would just get completely stretched out into a very thin strand of spaghetti, but not as delicious, about 1 atom thick. And luckily, there are no black holes even remotely close to our vicinity, so you don't have to worry about that either. So, all right, I'll stop there. Is there any questions?
Sure, we have a lot of questions, so I'm going to head back and try to get as many in as possible. So here's a really interesting question. If you have a balloon in space, will you fly?
Ooh, good question. So if you were to fill up a balloon with air and you brought it out into the vacuum of space, that's a pretty significant difference in pressure. So all that air in that balloon would want to escape. So, whether that is making it pop, or it would actually condense down and freeze, because any air that's in there would just want to become solid. So it'd shrivel up pretty much. That's most likely what would happen, actually.
Very cool. Interesting. And we have questions for how hot is the sun?
The sun at its surface is about 10,000 degrees Fahrenheit. If you were to travel into the core, it would be millions of degrees.
Awesome. And let's see. We did that one. Oh, yes. So would you be able to go into space without a spacesuit if you had an air tank, kind of like when you go under the water?
So you would still need a spacesuit, because you would still need to be insulated. You would still need protection from blasts of radiation. And in general, yeah, I think even if you had the air that's in your body would still be trying to escape. So just a air tank wouldn't be enough. You would need a full insulated suit that's pressurized in order to survive for a long amount of time.
Awesome. And I think we just have time for just one more question. Have people also wondering, what do people eat when they're in space, like on the space station?
Yeah, so that's a good question. I don't know specifically about the diets of a whole lot of astronauts. I do know what you can't bring into space. So you can't bring anything that will make crumbs, because crumbs will just float around and astronauts can inhale them, and then that can go into your lungs and that can be really bad. So nothing that makes crumbs, nothing that's messy. I know there's a lot of like astronauts eat dehydrated food, which a lot of the times, yeah, I'm sure that's the case. But I'm not sure super about the specifics of what they eat.
Awesome. Well, thank you so much, Katie. I know I learned quite a bit, especially about black holes. Sounds a little bit freaky. And I want to thank you all very much for coming. So Katie, if you want to say your final goodbyes.
Yes, thank you, everyone.
Thank you. And I hope that you all enjoyed. I'm so sorry that we didn't get to all of the questions. There were a lot. You had great questions, and I wish we could answer all of them. But you can head to mos.org/mos at home for other virtual offerings. You can check out this program that Katie used. It's called NASA Eyes. So you can go to eyes.nasa.gov. And if you enjoyed this program and are willing and able to support the museum, you can head to engage.mos.org/welcome. Thank you all very much for coming, and we'll see you all next time.